Okay, so the important word here is them saying prove, right? And when it comes to trig identities, when it's talking about proving something, what it essentially means is you're going to do whatever you can to the left side, right? This is the side we're going to like do some changing to, right? This side, the right side stays the same, okay? We are trying to get the left side to equal to the actual right side, okay? It's kind of the idea here. So let's look at this. I know I want to make it equal to tan x. I have sine x times secant x. My objective is always, always, always to see, is there a way I can get all of these things to be sine or cosine so that I can cancel things out. So this secant bothers me the most about this guy here. So essentially what's going to happen is I'm going to leave this guy the same, and this guy I'm going to turn into 1 over cosine x. Okay? Again, this side still says tan x. I'm not changing him yet. Well, if you look at this here now, sine x times 1 over cosine x, well, I'm just multiplying the two together. That could be written like this. Sine x over cosine x. Which if I go back up to my identity sheet and I look up here at what are some of the identities that I could use here, quotient identity, tan theta is equal to sine theta over cosine theta, or sine x over cosine x, right? So that quotient identity tells me that this would just become tan x. So then now I've taken the left side and I've made it equal to the right-hand side. Okay? Does that make sense?
Yeah, that was an easy one.
Yeah.
Hey, sweetie.
Hey, how's it going, sweetheart?
Love you.
Love you too.
Well,
I'm recording right now too. This is great. This is great. This is great.
Get on your knees and
Hold on, hold on. So the other thing about this guy here, again, whenever I see something written like this, the 1 over cosine x, I want to turn it into that. So I want this to be 1 over cosine x. Now, as I've told you before, I really don't like when things are conjoined together. So what I am going to do is go 1 over sine x times 1 over cotangent x. I'm going to break them apart so I can treat them kind of individually. Okay? I'm going to leave sine x alone as it is for right now. Okay? And I'm going to look at this 1 over cotangent x, right? Anything that has sine on it, I'm going to kind of leave alone, unless I have to maybe work with it. But the 1 over cotangent x, let's go back up to our identities here. Where can I see that? I see a reciprocal identity. 1 over cotangent is actually tan theta, right? So 1 over cotangent can actually be written as tan x. This guy we're going to leave the same, 1 over sine x. Now again, my objective is always, what can I do to this guy here to maybe make it sine, cosine, whatever? Well, there is that quotient identity. So 1 over sine x times sine x over cosine x. So I've made my changes. I have 1 over sine x, I have sine x over cosine x. Now is when I can look at it and go, are there things that I can cancel? Yep. Sine x cancel each other out. This all becomes 1 over cosine x. Okay? Left side equals the right side. Okay? Okay, I'm recording, buddy. So that's that guy there. Pretty straightforward one. Okay? Pretty straightforward one. Let's try a couple more of these guys. I'll pause this for a second, see if you guys can. Let's take a look at this guy here. We're starting to get one that's a little bit more complicated. So we want it to look like tan squared x minus cotangent x. That's a lot, right? We're trying to change the left-hand side and get it to look like that there. Where these ones become difficult is I'm trying to turn this guy into tan and into cotangent. That makes it a bit more challenging. So the first thing that we look at with this guy here, what sticks out to you right now? Is it the squared? Right? Immediately when I see this secant squared x and that, I'm thinking Pythag identities. So I'm going to go up and look at my Pythag identities here. I'm going to say, well, what are my Pythag identities with secant and what was the other one? Cosecant. Okay? So here's the one with secant. Here's the one with cosecant. Right? If I start to see this guy here, I'm like, maybe there's some things that I can do right now. So secant squared theta is equal to this guy right here. I know on the right-hand side I wanted a tan, right? I didn't get one in Asia because it was way too hot and I stayed under the sun. But I wanted a tan.
Woo!
Okay. I want a tan, and what was the other thing I wanted to get as well on that, on the other side of the right-hand side? I wanted a cotangent, right? So when you look at this guy here and I see cosecant right there can give me this, and secant can give me that, I'm going to actually put those two things together. So secant turns into 1 plus tan squared x, I believe. Yeah. Minus 1 plus cotangent squared x, right? Gentlemen, earbuds out, phones in the pockets, eyeballs up here. Okay? So now we got this, do it now, let's go. So I've got 1 plus tan squared x minus 1 plus cotangent squared x. Okay? If this is the case, I'm now going to distribute that negative throughout. Minus 1 times this, so it's going to become 1 plus tan squared x minus 1 minus cotangent x. What happens now? 1 minus 1 disappears. Tan squared x minus cotangent squared x. Hey, that's what I was looking for all along. Tan squared x minus cotangent squared x is equal to the right-hand side. Okay? So what I'm going to do is pause this guy here, and then I'm going to let you try this one beneath here and see, can you do this one here on your own? And then we'll work through it together as well. These ones should only be like a few steps. I'm sure, one of them is going to be a little bit tougher than the others, but.
So the x is just the little.
Okay. Again, when I see something that looks like this guy here, what do you notice on the other side? I see like cosecant squared x minus 1. So I'm looking at that and going, is there a way for me to change this guy into something or change this guy into something? I already have a cosecant squared x, but it's got to be a binomial here, so it's going to be a bit more challenging. So because we know what we're changing here, can you look at this guy here and think, what can I change?
You change cosine.
What do you, so what is that going to become?
And 1 minus sine.
So cosecant squared x could become, based on a Pythag identity, you say 1 minus, well, it is cosine, so it's 1 minus sine, right?
Yeah.
Times 1 minus sine squared x, right? Yeah. So we can try this guy here. If you multiply this throughout here, what's going to end up happening? So I can distribute this guy throughout now, if you wanted to. Well, what would you, so like from here, because it's saying this guy multiplied by this guy. If I change the cosecant into 1 minus sine squared x, because that's what it becomes, yeah, and I distributed, because just think about it, it's still a coefficient. Yeah. Cosecant squared x is still a coefficient. So if I multiply this throughout here, what ends up happening? I end up getting cosecant squared x minus cosecant squared x times sine squared x, which looks really weird, right? All I did was multiply this with the 1 and multiplied it by the sine squared x.
Multiply it?
What's any different than this? It's a binomial.
Oh.
Right? We got a binomial here.
You just move
That multiply that, that multiply that.
Because the sin x is still there.
The sin x is still there. Well, what? Okay,
You can't actually multiply.
let's put it this way. if I had 4 outside and 1 minus like b, what would that become?
Oh, 4B.
Like 4 minus 4b. That's all that happened here. I can't really combine them together, but now that I've done this here, if you look at it and you're like, well, I have cosecant squared and I have minus. Can I do anything to this to maybe turn it into 1? Yep. This guy becomes 1 over sine squared x. This one stays sine squared x. This guy still stays cosecant squared x.
Get rid of the sign.
Now I can cancel this, and it becomes cosecant squared x minus 1. That would be, in my mind, a more challenging one, because as soon as, Hannah, you're totally right when you see this here, this kind of looks like nonsense, right? Where it was like, he's on the outside, if I distribute him throughout, it kind of goes kind of wonky. But is what it is, I guess. But anyway, we broke it apart. The big piece of advice I would give you on this here, Jackson, your idea to take this guy here and turn it into a Pythag identity because he's a binomial is where your thinking should go, right? Because this is just one like trig identity times another trig identity, right? We got 2 things multiplied by each other, and then now I have a binomial. So the only way to turn a singular thing into a binomial would be to use a Pythag identity. So like, I'm hoping that you see here, like, my first step would be to use some sort of Pythag ID. Okay? So you'll see, let's see if was there another way to do it? Oh, I like that. So here's what's the most beautiful thing in my mind about these guys here, is that you can write them in different ways. So they wrote this one as 1 over sine x. So this became 1 over sine x. Cosine squared x became the same thing. So now I ended up with cotangent squared x. And they used the Pythag identity of cotangent squared x to end up with the cosecant squared x minus 1. So the other method here, so I'll draw it here.
Yeah, I need to draw it.
Cosecant squared x, cosine squared x. They turned this guy into 1 over sine squared x and left that as cosine squared x. Multiplying these 2 things together, cosine squared x over sine squared x ends up becoming cotangent squared x because of the quotient identity.
Oh, and cotangent, it just
And
becomes-
cotangent as a Pythag identity just becomes cosecant squared x minus 1.
Oh, that's cool.
Right? So this is probably the most frustrating part of Pythag or trig identities, is that you can do it this way, you can do it the way that I did it, and both are correct. Which one would make more sense to you, actually?
I don't know, what's that? Good.
They
Like,
both seem, yeah.
To figure it out, I probably would have used the other one, but I would have sat there for a while.
Yeah. Anyway, so that's those guys there. Why don't you try some of these guys on your own? I'm going to freeze this video here because I don't want to go too much longer, but those are like perfect examples of what we want to be working with.